we are going to cover a topic that is going to affect a lot of what we do going forward with special right triangles. You will be using special right triangles for the rest of the year, starting with the section that we have coming up in this chapter. So these are going to be very important. This is something they expect you to know, but because some of you ended weirdly last year, some of you did Algebra 1 last year, some of you did Algebra 1 2 years ago, I don't know exactly how much you have of this, so I'm going to take time to go back and review this concept like you've never seen it before. So we're going to go ahead and get started. If you have questions, please make sure you pause the video, go back, be prepared to ask questions in class when we get there. Let's go ahead and get started. Today we're going to be talking about a topic called simplifying radical expressions. So this is a radical expression. We're going to take and simplify it. In order to simplify it, we are going to break it down into what we call a perfect square and a non-perfect square. A lot of times they'll call them nice and not nice numbers. So the nice numbers are going to be what we call perfect squares. This is the list of the perfect squares. Guys, the numbers that are perfect squares are 4, 9, 16, 25, 36. These are all numbers that when you take the square root of them, you get a whole number. You do not get any decimals. They don't happen very often. Now there are bigger ones than 144. They keep going. Square root of 400 is a common one. Square root of 225 is a common one. But these are the most common. Now, 1 is also a perfect square, but that doesn't break anything down, so that's not going to help us, so I didn't even list it here. You do need to know what the square root of these is, but I'm hesitant to write them down because then people think these are the perfect squares. Guys, please make sure you understand. The highlighted numbers are the perfect squares. Right? The numbers I'm putting them equal to are going to be the answer after you take the square root, which is for 4, 2, for 9 it's 3, for 16 it's 4, for 25 it'd be 5, for 36 it'd be 6, for 49 it'd be 7, for 64 it'd be 8, for 81 it'd be 9, for 100 it would be 10, for 121 it would be 11, and for 144 it would be 12. Now, as I said, they keep going. That is not the end, but those are the most common ones that we're going to use. So that's the list we're going to put on here. Now, please understand that the 2, 6, all these numbers, these are not perfect squares. The numbers that are the perfect squares are the 4, 9, 16, 25, etc. So when we're breaking a number like 20 down, this is going to require you to use your calculator if you do not divide well in your head, so grab them. We're going to try to set this up into two separate radicals. The first radical is going to be a number out of this list, if it will break down. And you start small, so you start with the first one. Does 4 go into 20? Yes, it does. So you put the 4, the nice number first, the perfect square first. And then you say 4 goes into 20 5 times. Okay, 4 times 5 would give us 20. Then we take the square root of 4, which the square root of 4 would be 2. And then we write our answer down here. 2 square root of 5. This is also said 2 radical 5. That's another way to say that. But that would be considered completely simplified because none of the numbers in the list will still divide evenly into the number that is under the radical. 4 won't divide evenly into this, and all the other numbers are bigger than that. So from there, let's keep going. And I just have a lot of examples. There's no other topic. This is the only thing we're doing. So from here, we would break this down. We're looking for the perfect square, the nice number, and what would be left over. So if you start dividing 12 by the numbers in that list, 4 will go into 12, so 4 is going to go on our nice side. 3 would be what you get when you say 4 goes into 12 3 times. Once you take the square root, don't forget, you do not put the square root symbol again after you take the square root. The square root of 4 is 2. So it will be written 2 square roots of 3. And we know that's done because 4 is bigger than that, and we can't get any of those numbers from that list to break down into that 3. For 90, we're going to start by breaking this one down into a nice and a not nice number, a perfect square, and what's left over. The perfect square in this case is going to be the square root of 9. And if you say 9 goes into 90, that would leave you 10 for the other one, or other radical. The square root of 9 is going to be 3. And that would be written as 3 square roots of 10. Now, listen to me. How do you know to stop? You look at that list and you try dividing. Can 10 divide by 4? Can 10 divide by 9? I know it can divide by 2 and 5, but they are not on that list. They are not perfect squares. You only break it down if it can divide by one of those perfect squares. Because it cannot, you are done at that point. You know you need to stop. Okay, let's keep going and try some more. So for this next one, a little bit bigger number. When you look at this number, you need to understand that this is going to break down. When you break this down, this is going to break into 2 radicals, one that is a perfect square and one that is not. So this is going to require you to take out your calculator and just start dividing. Start dividing that number by numbers on that list, and if you take and divide that 52 by 4, that's going to give you 13. So 4 is the nice number. 13 would be what you get left over. The square root of 4 is going to be 2. So that would leave us 2 radical 13, or 2 square roots of 13. Now again, you would try to break that down if you could, but it won't divide by 4, it won't divide by 9, and the rest of the numbers are bigger than that. So, from there, 72. Now this one's going to be unique, guys, because 72 can be broken down into lots of different numbers. Because of that, you can start this problem in different ways and end up at the same answer. I'm going to show you one option, and then I'm going to show you a shorter option, and why picking bigger numbers at the beginning might be easier. So I'm going to say that I recognize that 72 will divide by 9. 9 goes into 72 a total of 8 times. When I take the square root of 9, that's going to give me 3. I take that 3 and put it out in front, and that'd be 3 square roots of 8. The only problem is, if I look at that list of numbers and I try dividing 8 by the 4, the 9, the 16, it will divide evenly. It will still break down into one of those numbers. I keep that 3 out in front, and I break this one into 2 pieces, 2 radicals. The square root of 8 will divide by 4 as my nice number, my perfect square, and 4 goes into 8 2 times. Now guys, watch what happens here. These are right next to each other. This means multiplication. So when I cross this out and I put that the square root of 4 is 2, that means I need to multiply these two numbers that are outside my radical now, because they're next to each other, and it would make it 3 times 2, which is 6 square roots of 2. I know I'm done at that point because I have no other perfect squares that will divide into that 2. So from there, I'm going to show you a different way to do this problem, or break it down, and that's going to be to start with a bigger number. And you don't have to do it this way, guys. I just want you to know that there's another way to approach this problem that would take less time. If you look through that list and you start going through and dividing by the numbers, 72 will divide by 36. So my first number, my nice number, would be 36. And 36 goes into 72 a total of 2 times. So I'm going to put my 2 right here. The square root of 36 is 6. So I'm just going to cross this out, put my 6 up here. And my final answer would be 6 square roots of 2. It's not anything that makes it right or wrong compared to the other one. I get the exact same answer. I just went through a shorter process. There is an advantage in that, and that you can make less careless errors, but you have to recognize that the bigger number goes into it. I will accept the work either way. And actually you can start that one by dividing by 4 in another number. There are so many different ways to get to that final answer. Okay guys, as long as it's simplified all the way, that's all that matters. Now, I have two on here that I want to talk about that are kind of special cases, and that's to start with this 34. If you start dividing 34 by 4, doesn't work. It has to divide evenly, guys. You start dividing 34 by 9, nope. If you divide 34 by 16, doesn't work. And then all the, 25 will work. And then all the numbers after that are going to be bigger than 34. That means it will not break down into anything that is a perfect square. Yes, it will break down into numbers. It can divide by 2. It can divide by other things. Guys, that's not the point. The point is it won't divide by a perfect square. Because of that, this is as simplified as this can possibly get. So the square root of 34, when you simplify it, is just the square root of 34. Oops, sorry guys, my tablet's acting strange. Try again. Okay. We're going to give it a minute, guys. Hold on a sec. There we go. So, for the next one, it's unique also because, guys, the number itself is a perfect square. You've been doing square roots that are like this for a long time. Don't change what you were doing. Don't break 36 down into 9 and 4 and try it. No. The square root of 36 is a perfect square. The square root of 36 is 6. You don't do anything else to it. You just put 6. No radical, no nothing. The square root of 36 is 6. Okay. So from there, the next one. Now this is a little different because we start with the number out in front, but the process to break down the number is exactly the same. These are our last two, so let's go through and work these out. The 45 will break down into two numbers. Out of that list, you start divided by by 4, that won't work, so you go to 9. 9 does work. 9 goes into 45, a total of 5 times, so my nice number is 9. My leftover number is 5. I'm going to take the square root of 9, which is 3. Now remember, these things were next to each other. Because they were next to each other, that means multiplication. So when these numbers are outside the radical, you need to multiply them. So 2 times 3 would be 6 square roots of 5. I know it's done because 4 won't divide into it, and every other number that's in the square roots that's a perfect square is going to be bigger than 5. Now, our last one, you'll have to look a little bit maybe. Some people will see it right away. I did not. When I broke this down and I started looking, I had to go through and divide all of them and see where it was. I started dividing by 4, by 9. None of them worked. 16, 25, 36, until I got to 49. 49 will divide into 147. 49 goes into 147 3 times, so that's my leftover number. I'm going to cross this out because the square root of 49 is 7. And remember, because they're both outside and they're next to each other, that means multiply. So 5 times 7 puts it at 35 square roots of 3. So from there, make sure that you get this notes recorded, and we will be doing an assignment on this the next time that we come in.